Very good afternoon. In this video, I am explaining the difference between star schema and snowflake schema. First, we understand what is star schema and snowflake schema. Both these star schema and snowflake schema were used to data model design in Power BI. So here is a simple differences between star schema and snowflake schema. Star schema, the standard definition of star schema is a data model where the fact table is at the center, directly connected to dimension tables. So in the star schema, the fact table is located at the center and the dimension tables are directly connected to the fact tables. Dimension tables are denormalized, meaning they contain all attributes in one table without further branching. So, dimension tables are denormalized. That means all, all the data presented in one table. That means some small tables are together into a one big table. So, that one table contain all the attributes related to the data. Key features of star schema. Simple and easy to understand. So the star schema is simple and it is very easy to understand. Dimensions have no further normalization, that is no subtables. So in this the dimension tables are not normalized into subdimension tables. It is all the data located in one dimension table. Fast courier performance due to fewer joins. So in star schema, the joins between fact table and dimension tables are fewer. So it has fast query performance. Advantages of star schema. Simplifies reporting and querying. So star schema simplifies reporting and querying. Faster performance because there are fewer joins. So, so the performance of the reports with the star schema is very high due to the presence of fewer chains between fact and dimension tables. Disadvantages of star schema. It requires more storage due to redundant data in dimension tables. So in star schema, all the dimension tables are not further categorized. So the data is located in the data is stored in one table, so it requires more storage in the Power BI. So it is one of the disadvantages in star schema. Not ideal for very large and complex data sets. So it is not possible to use the star schema for very large and complex data set. It is only suitable for small and simple data sets. Example, fact table. Here we understand it with one by taking one example. Fact table. Fact says connected directly to dimension tables, dim product, dim region, dim customer, dim date. So in this example, the fact table is fact sales is directly connected with dimension tables. Those dimension tables are dim product, dim region, dim customer, dim date. Here, yes, we understand it by taking a example. This is a one star schema. In this, the fact table is sales table. It is located in the center, and the location, date, product, and customer are the dimension table. Those are arranged around the fact table. There is a direct join between fact table, dimension table to fact table. It looks like a star. So the name itself is called as star schema. It is it has fast performance due to fewer joins between fact table and dimension tables. The disadvantage of star schema is it requires more storage and it is only suitable for simple and less complex systems. It is not suitable for very large and complex data sets. Here we understand the Snowflake schema also. Definition. A data model The standard definition of Snowflake schema is a data model where the fact table is at the center, connected to dimension tables, which are further normalized into subtables. It is also like a star schema, but the difference is the dimension tables are normalized. In star schema, the dimension tables are denormalized. That means many small tables can be converted into one table. In this, one big table can be further categorized. So in this also the fact table is located at the center. The dimensions are located around the fact table, but the dimension tables have subtables. This is the difference between star schema and snowflake schema. Dimension tables are split into multiple related tables. So the dimension tables are split into one or more tables. Key features of snowflake schema. Dimensions are normalized, so broken into smaller tables with relationships. So the dimension tables are categorized, and there is a link between those dimension tables, and from dimension tables to fact table. This is some more complex structure with multiple levels of joins. So, as the snowflake schema is complex because of multiple levels of joins. It is not ends in only one level. It has multiple levels. Advantages: save storage space by eliminating data redundancy. It saves the storage space by eliminating the data redundancy. So in this Snowflake schema, it doesn't require more storage. It is good for handling very large and complex data sets. So when we work with larger data sets, it is good for using Snowflake schema. Disadvantages: slower query performance due to multiple joins. The disadvantage present in the Snowflake schema is the query performance is slower due to multiple joins. So in star schema, the query performance is high due to fewer joins. Another disadvantage is it is harder to understand and maintain compared to star schema. So the understand and maintenance of star schema is also hard compared to star schema. The understanding and maintenance of star schema is very easy. Example: fact table. Fact sales connected to normalized dimension. Dim product category. Dim region country table. So here it is a snowflake schema. This also the central fact table is sales fact table. It is located at center. The dimension tables are product dimension, organization dimension, location dimension, time dimension. Each dimension table has another sub sub-dimension table. For product dimension tables, product category lookup is the another subtable. For organization dimension, branch lookup is another dimension table. For location dimension table, the state lookup is subdimension table. For time dimension, month lookup is another subdimension table. So there is a link between uh, product category lookup to product dimension, branch lookup to organization dimension. The state lookup is connected to location dimension. Time dimension is connected to month lookup. So it has a more than one level of dimension table. The dimension tables are subdivided. Key differences. Here are the uh, some bullet points differences between star schema and snowflake schema. Structure. Star schema structure is single level dimension tables. In snowflake schema, uh, the snowflake schema structure is multi-level dimension tables. So the snowflake schema has multi-level dimension tables. that is normalized. Star schema is denormalized. Query performance. In star schema, query performance is faster due to fewer joins. In Snowflake schema, query performance is slower due to more joins. Storage. Star schema requires more storage because of denormalized data. Snowflake schema requires less storage because of normalized data. Star schema. The complexity of star schema is simple and easy to understand. Snowflake schema is uh, more complex and harder to maintain. Star schema usage. We use star schema. It is best for smaller data sets or faster queries. Snowflake schema is best for larger complex data sets. When to use. So we understand the differences between star schema and snowflake schema. Now we understand where when to use and where to use this star schema and snowflake schema. Star schema use when query performance is critical. So query performance is our main task. We use star schema and storage is not a major concern. So there is no problem with storage. We use star schema. Ideal for reporting and BI tools like Power BI. So star schema is best suitable for BI tools and Power BI. Snowflake schema. Snowflake schema uses when storage optimization is important. So we have less. We want to use less storage to store the data model. We use Snowflake schema and data redundancy must be minimized. Snowflake schema is suitable for large enterprise data warehouses. So if we work with large data warehouses, we use Snowflake schema. These are the main differences between star schema and Snowflake schema. We must understand those differences and analyze them to create a Power BI reports. So data model plays a vital role in uh, report creation and performance. So we select based on the requirement and usage of the storage. So we choose based on the storage and maintenance of the star schema. Maintenance of the schema. So if we work with small data sets and we want more performance, we use star schema. If we work with large data sets and store performance is not a issue, and we use less storage to store the data model, we use Snowflake schema. These are the uh, complete details about star schema and Snowflake schema. I hope this video helps you to understand star schema and Snowflake schema. Thank you.